Okay, October, November 2024, paper 4, variant 2. Question 1. A rocket has an initial mass of 7.4 times 10 to the power of 6 kilograms. Can I find the initial weight of the rocket? Yes. Weight equals mg. 7.4 times 10 to the power of 6 times 9.8, which would basically be almost 7.4 times 10 to the power of 7, or maybe 7.3. Okay, 7.4 times 10 to the power of 6 times 9.8 is 7, yeah, 25, yeah, 7.25 times 10 to the power of 7 newtons. Define the term weight. What is weight? Weight equals mg, or weight is the gravitational force on an object, right? It is the gravitational force on an object. On an object. Figure 1.1 shows part of a speed time graph for the rocket as it leaves the ground. This is a speed time graph. Describe the motion of the rocket from O to A and then from A to B. From O to A, what's happening to the speed? The speed is increasing. What about, or what type of acceleration? That's the question. What type of acceleration? Yes. From A to B, it's also accelerating. It's also accelerating. So from A to B, you'd say speed increases with an increasing, okay, increasing acceleration. Why? Because it's curving upwards towards the y-axis. While from A to B, the speed increases with a constant, okay, constant acceleration. Draw a tangent to the graph at time 400 seconds and use this to calculate the acceleration of the rocket at this time. Show your working. So, can I find the tangent at time 400 seconds? Let's zoom in a bit. At 400 seconds, so it reached this point, okay, which is 400, and this is 4,200. 4,200. Can I draw a tangent? Yes, you can draw a tangent. For example, let me use this line, which is a straight line. Okay, when you draw a straight line at this point, you can extend this line all the way up to, for example, here. Yeah, this would be a straight line. This would be a straight line. So what are the coordinates? What are the coordinates of the second point, of this point? The coordinates of this point would be, yes, 190, yeah, around 190 and 0. Right, 190 and 0. So now you have 2 points. Now you have 2 points. 400 and 4,200 and 190 and 0. Can I find the slope? Y2 minus y1 over x2 minus x1. Let me remove this line. You have to draw this line. Actually, you have to draw this line. So let me draw it again using my free hand. But again, you're drawing using your ruler. Okay? Draw this line, this tangent line. Okay. To find the slope, y2 minus y1 over x2 minus x1, 4,200 minus 0 over 400 minus 190. y2 minus y1 over x2 minus x. So what's that? That will give you 400 minus 190, 190, which is exactly 20 meters per second squared. Definitely, if your coordinates aren't exactly 190, it could be more or less a little. Yes, it would be still acceptable. If the acceleration is 21, 22, or the acceleration is 19 or 18, it would also be acceptable. Rockets are used to launch satellites into space. When the satellite is released, the rocket returns to Earth. Explain in terms of forces why the rocket reaches the terminal velocity. Terminal velocity. How does it reach the terminal velocity as it's falling back through the atmosphere of the Earth? As it falls down, what happens as the speed increases? Okay, as the speed increases, the resistive force or the air resistance. Okay, air resistance increases until finally the weight would be equal to the air resistance, meaning that it has a zero resultant force. It has a zero resultant force and moving with zero acceleration, or basically it's moving with a constant speed. Okay. Yeah. Figure 2.1 shows a golfer about to hit a golf ball with a golf club. Define momentum. What is momentum? P equals mv. So it is the mass times the velocity of that object. The golf club is in contact with the ball 4 to 5 times 10 to the negative 4 seconds. The velocity of the golf ball as it leaves the club is 41 meters per second. It has a mass of 0.046 kilograms. Can I find the impulse? Yes, impulse is mv minus mu. mv minus mu. Basically, it was at rest. Initially, it was at rest. So what's mv? The mass is 0.046. You do not need to convert it. Times 41. Times 41. What's 0.046 times 41? This is 1.886 or 1.9 newtons dot second or kilograms dot meter per second. Can I find the force applied to the ball? Yes, I can find the force. Why? Because impulse equals force times time. So force equals impulse over time. Impulse is 1.9 and the time is very small, 5 times 10 to the negative 4. What is 1.9 divided by 5 times 10 to the negative 4? This is 3,800 newtons. 3,800 newtons. Say two energy resources for which the radiation from the sun is the main source of energy. Any two sources, any two resources. So we can say hydroelectric. Okay. We can say solar energy. We can say wind energy. Even fossil fuels. When turbine is used to generate electricity, the useful output is 6,000 joules. The kinetic energy hitting the turbine is 11,000 joules. The velocity is 6.3 meters per second. Show that the mass of the air hitting is approximately 550 kilograms. Okay, how can I find the mass? If you have the kinetic energy and you have the speed, can you find the mass? Yes. Kinetic energy equals half mv squared. Half mv squared. To find the mass, it would be basically 2. You need to multiply by 2. So basically to find the mass, it would be mass equals kinetic energy times 2 divided by the v squared. Or 11,000 times 2 divided by v squared, which is 6.3 squared. What's 11,000 divided by 2? Times 2 divided by v squared. 6.3 squared. This is 554.29, which is 554. Yes, which is very close to 550 meters per second. Kilograms, I'm sorry, not meters per second. Okay, kilograms. Calculate the efficiency. Can I find the efficiency? Yes, efficiency is the useful output over the total input. Efficiency is the useful output over the total input, or the smaller number over the larger number. Smaller number is 6,000 over 11,000. 6,000 divided by 11. Okay, times 100. We can multiply by 100 to find the percentage, which is 54.5%. Can write it down as 55%. Tidal energy and wind energy are both renewable resources, so suggest one reason why tidal energy is more useful than wind. Why would tidal energy be more useful than wind? Well, simply because the tides are quite reliable. Tidal energy is reliable. How is it reliable? Okay, tidal energy is reliable. We know the timings when the high tide and when will the high tide be and when will the low tide be. We know the timings. Okay? It depends on the moon, depends on. So we do know the times of the high tides and the low tides, but we do not know. We don't really know when we would have strong wind or not that strong wind. Okay. Figure 4.1 shows a pressure cooker on electric heating element. The pressure cooker is half full of water. As the water is heated, some water evaporates. Describe two differences between evaporation and boiling. Okay, that's simple. Boiling, okay, happens at a specific temperature only, while evaporation happens at any temperature. Evaporation only happens at the surface, while boiling happens throughout the whole liquid. As the water is heated, the pressure of the gas inside the cooker increases. Explain this increase in pressure in terms of particles. Why does the pressure increase? Okay, as it gets heated, this is a constant volume, right? Isn't it? It is a constant volume. So basically, hmm, as kinetic energy increases, the speed of the molecules increases, so they hit the walls, okay? Hit walls faster and harder, in and more frequently. When they hit the walls faster and harder more frequently, what happens? Increasing the force and pressure, because pressure equals force over area, or pressure is directly proportional to the force. On a sunny day, the temperatures of a black tarmac road and the air above the road increase. Black road. Explain why the surface temperature of the tarmac increases. The surface temp. Why does it increase? In the sun. Because black is the best absorber of what? Black is the best absorber of infrared radiation. Infrared radiation. State the method of thermal energy transfer from the tarmac to the air immediately above the road. The air immediately above the road, how would it increase its temperature? How will it increase its temperature? Due to conduction. Why? Because these air molecules, they hit the road, right? They kind of collide with the tarmac. So as they hit the road, they gain kinetic energy due to this vibration by touching other molecules. Yes. State the main method of thermal energy transfer from the air immediately above the road to the rest of the air. To the rest of the air. How? This is due to convection. Yes, this is due to convection. Explain why the surface temperature of the tarmac is higher than the surrounding air temperature. Why is the surface higher than the surrounding air? You'd say yes, because the black is a better absorber of infrared radiation. And if you think about it, the thickness or the volume, the amount of tarmac in the road is definitely much, much less than the amount of air above the road, right? No matter how thick the road is, the air above it would definitely be much more. The volume of the air would be definitely much more than the volume of the tarmac. Therefore, the volume of the tarmac would absorb this energy, tarmac road would absorb this energy and temperature would increase. What about there? It would absorb energy and the temperature would increase, yes, but not as much. Why? Because of the volume of this road. So you need to say that the black surface, okay, you can say that the black surface is a better absorber, yes. Black surface is a good absorber of of infrared radiation, and the volume of the tarmac is much less than the air. Than the air. Okay. A student plays the violin near the doorway, okay, to a large room. State the wave effect that allows the young teacher to hear the sounds from the violin at the position he is standing at. How can he hear the sound? Due to diffraction, yes. Diffraction. This is easy. Calculate the frequency. You have the wavelength, you have the speed, so frequency equals speed over wavelength. 340 divided by 0.75. What's 340 divided by 0.75? 453 hertz. 453 hertz. A violin produces sounds in the frequency range 200 hertz to 3,800 hertz. The width, okay, of the open doorway is 0.75 meters. Explain why the young teacher hears the frequency calculated in AII, okay, which is 453, clearly, but finds the frequency of 3,500 hertz much harder to hear. Okay, it isn't that tricky at all, to be honest. Why? Because as you increase the frequency, what happens to the wavelength? As you increase the frequency, the wavelength decreases. And therefore, what happens to the amount of diffraction? The teacher can hear the sounds due to the diffraction, right? So what happens to the amount of diffraction? The diffraction decreases when you decrease the wavelength. So as frequency increases, wavelength decreases, right? The wavelength decreases. Therefore, the amount of diffraction decreases. Okay, diffraction decreases. It doesn't spread as much. Okay, now you have a mirror which is placed at point X. On figure 6.1, draw a light ray from the violin to point X, and then to the teacher, draw and label the mirror, and add an arrow to the ray to show how the teacher sees the student. Okay. So from the student to the teacher, okay, from the violin to the teacher, we can draw a line all the way to X, straight line to X. We need to place a mirror at X. You need to place a mirror at X to show the reflection of this light that will go from the violin to the teacher. So you need to draw the line this way. This is the ray. It is reflected, so it's moving from the violin, okay, from the student all the way to the teacher, right? How can I place the mirror at point X? If you place the mirror almost this way, okay, say this is the mirror, this is the mirror. Why would this position be much better than, for example, okay, if I draw a wrong mirror, okay, if you draw a wrong mirror, it would be, for example, this way. This would be a wrong mirror, this blue line. This is wrong. Why is this a wrong mirror? Because the reflection would almost be reflected back to the student, okay? Reflection would almost reflect back to the student. Another wrong mirror, for example, would be this way. Why? Because the angle of reflection would be quite large, right? The angle of reflection would be quite rare. So you need to kind of place the mirror this way. Why? Because the angle of incidence would be equal to the angle of reflection. If we draw a normal line this way at this point, yes, the angle of incidence would be equal to the angle of reflection. If you want to kind of bend the mirror a little bit more, just slightly more. Okay, so for example, okay, this might be the mirror. Okay, this is the mirror, and then you draw the normal line and show that the angle of incidence, this is the angle of incidence, is equal to the angle of reflection. Do I have to actually state where the angle of incidence and the angle of reflection are? No, you do not need to do that, but you should draw the rays, one ray moving from the violin to the mirror and from the mirror back to the teacher. You need to draw the arrows to show the direction of the motion of this light, and you need to place the mirror correctly. Okay. Okay. Question 7. A washing machine has an electric motor and an electric heater. The heater has a resistance of 25 ohms and the power supply has an electromotive force of 230 volts. 230 volts. State the meaning of electromotive force. What is electromotive force? It is the electric work done. It is the electric work done by the source, okay, by the source on a charge in moving it once around the circuit, okay, moving it around the circuit. Okay, so the whole difference between the EMF and the potential difference is that one of them is doing work and one of them is taking this work. Okay, so work done, EMF is work done by the source. Okay, by this, the other one, the potential difference is work done by the, yes, by the charge itself. Say the potential difference across the heater. This is a parallel circuit, so the potential difference across the heater would be 230 volts. Can I find the current in the heater? Yes. V equals IR, so I equals V over R. 230 divided by 25. What's 230 divided by 25? This is 9.2 amperes. 9.2 amps. The current in the motor is 1.6 amperes. Determine the reading on the ammeter. Can I find the reading on the ammeter? Yes, I can find the reading. Why? It would be 9.2 plus 1.6, 9.2 plus 1.6, which is 10.8 amps. How can I explain this? How can you explain this? Simply by saying that the total reading would be equal to the sum of all of the branches. Total reading would be equal to the sum is equal to the sum of all branches. Okay. A fisherman uses a high frequency sound waves. State the name of the sound wave which has a frequency greater than 20,000 hertz. Ultrasound. High frequency sound waves travel from the boat. Seawater, the speed is 1,500 meters per second. The seabed is 22 meters below the boat. Calculate the time taken for the boat to receive the reflected wave. What is a reflected wave? This is an echo. And the speed in the echo is 2 distance over time. To find the time, it would be 2 distance over speed. Basically 2 times 22 divided by 1,500. What is 2 times 22 divided by 1,500? This would be 0.029 or 0.03 seconds. 0.03 seconds. Or you can write it down as 0.029 seconds. Two significant figures is okay. Figure 8.2 shows a fish below the boat. Describe and explain how the reflected wave received by the boat from the fish differs from the reflected wave received by the seabed. So most of these waves hit the seabed and are reflected. Only some of the waves hit the fish and are reflected. So most of the waves, okay, pass and just hit the seabed and are reflected. But only some of these waves, very few of these waves, hit the fish and are reflected back. Therefore, when you think about it, the amount of energy or the amount of waves that are received are weaker. You can say that the wave is weaker. Why? Because the surface area of this fish is much smaller. The amount of waves that hit the fish and are reflected back are much less, right? Therefore, you'd say that the reflection is weaker. The reflected wave is weaker. It has a reflected wave is weaker. Why? Because the fish is so much smaller amount. So the reflected wave is weaker. Why? Because the fish is much smaller. Okay. Hmm. Okay, figure 9.1 shows a wireless charging plate. Wireless charge. The charging plate is connected to an AC power supply. The power supply is turned on. Describe the magnetic field around the charging plate in terms of its magnitude and direction. So if you have an AC power supply, AC power supply, how does the magnetic field in an AC power supply look like? Is it a constant magnetic field? No, it's not constant. What changes in this magnetic field in terms of what? In terms of magnitude and direction. Yes, the magnitude itself changes, keeps on increasing and decreasing. So the magnitude, okay, the magnitude changes, it increases, okay, and decreases. What about the direction? Direction also changes. Direction changes and is reversed. Okay, direction as well changes and is reversed. You can say it is reversed every half cycle. You'd find the North Pole on one side and the South Pole on the other side, and every half cycle keeps on changing. Why? Due to this alternating magnetic field. As the magnetic field changes, the current changes, the direction of the magnetic field changes. And we actually use this in the transformers. Okay, why does this act like a transformer? It does act like a transformer. Yes. How does it act like a transformer? Because of this magnetic field. When it changes, what does it do? Let's think about a transformer. What does or how does a transformer operate? Transformers operate by this changing magnetic field. So this changing magnetic field, what does this do? It cuts, right? It cuts the secondary coil, inducing, right? Inducing a voltage and an EMF, right? So the changing magnetic field cuts the secondary coil, producing an alternating or a an induced, okay, EMF and current. Basically, instead of saying define or state the method of operation of a transformer, he divided the question onto two smaller questions. Part A, in which you described the direction or you described what happens to this magnetic field, and part I, in which you describe what's happening in the secondary coil. That's it. It's a longer way of just saying what is the method of operation of the transformer. Suggests why the transformer made from the charging plate and mobile phone is not 100% efficient. Why isn't it 100% efficient? Because you have some energy lost to the environment. Yes, energy is lost to the environment, right? Okay. The mobile phone battery can be recharged. You have energy, you have the current, you have the voltage. Can I find the time? Yes. E equals VIT to find the time to be energy over VI. The energy is 4.5 times 10 to the power of 4, and the voltage is 12 volts while the current is 0.63. Can I find the time? Yes. 4.5 times 10 to the power of 4 divided by 12 times 0.63, which gives you a time of 5,950 5,950 seconds. Can I find the charge passing in 60 seconds? Not the total charge. Can I find the charge passing in 60 seconds? Yes. Q equals IT. You have the current, which is 0.63, and the time, which is 60 seconds. 0.63 times 60, 37.8 or 38 coulombs. Moving on to question 10. Carbon 14 is a radioactive source, a radioactive isotope of carbon. How does carbon 14 differ from an isotope of carbon 12? Okay, that's easy. Carbon 14 has two more neutrons and is heavier. And is heavier. All living organisms contain both carbon 12 and carbon 14 atoms. The ratio of carbon 14 to carbon 12 is 1 to 1 times 10 to the power of 12. The ratio. He's talking about the ratio. He didn't say the amount of whatever. He's talking about the what? The ratio of carbon 12 to carbon 14. Carbon 14 to carbon 12. So carbon 14 to carbon 12. The ratio now is what? Is 1. Let's say to 1. Let's say to 1. What's 1 to 1? What do I mean by ratio 1 to 1? For example, if you had 40 carbon 14, then you'd have 40 carbon 12. This is what I mean by ratio 1 to 1. Yeah, the same amount. So it's actually 40 to 40 times 10 to the power of 12, right? This is the initial amount, right? It's almost 1 to 1. When an organism dies, no new carbon is absorbed. No new carbon is absorbed. The amount of carbon 12 in the dead organism remains 12. Read it carefully. The amount of carbon 12 in the dead organism remains fixed. This amount remains fixed. Describe how the amount of carbon 14 in the dead organism decreases with time. So, when he dies, carbon 14 is an isotope, a heavier isotope, right? And we know that heavier isotopes are more unstable. Heavier isotopes, when you increase the neutrons in an atom, what happens to this atom? It becomes more unstable, right? Becomes more unstable. So what happens? The amount of carbon 12 remains the same, but the amount of carbon 14 decreases with time and is halved. There's a half-life. What is the half-life? 5,700. Okay, so the amount of carbon, okay, of carbon 14 decreases, you might say, with a decreasing rate, with a decreasing rate with time, and is halved. can say half-life, every 5,700 years. Is halved every 5,700 years. So now, 14 keeps on decreasing while 12 remains the same. Carbon 12 remains the same. A sample of wood contains carbon 14 to carbon 12 in the ratio of 1 to 40 times 10 to the power of 12. 1 to what? 4, I'm sorry, 4 times 10 to the power of 12. So, carbon, again, carbon 14 to carbon 12, 1 to 4. Does this mean that the carbon 12 has increased? No. This means that the carbon 14 has decreased. How so? It was initially 1 to 1, and now you're saying 1 to 4. So carbon 12 has increased. No, carbon 14 has decreased. How is that so? We said that carbon 12, for example, the amount or the initial amount was 40 times 10 to the power of 12, right? Initially it was 40 to 40. 40, initially it was what? 40 to 40, which is 1 to 1. Finally, it's 1 to 4. What do I mean 1 to 4? The amount of carbon 12, isn't this 12? This is 12. The amount of carbon 12 remains the same, but the amount of carbon 14 has become 10. Why has it become 10? Because it has decreased. Is this ratio 1 to 4? Yes, it is 1 to 4. 1 to 4. So the amount of carbon 14 has decreased from 4 to 1. From what? From 4 to 1. How did it decrease? It was halved. How many times? It was halved. How many times? From 4 to 1, you divide it by 2, 2 times. 4 divided by 2 is 1, is 2, I'm sorry. Divide by 2 again is 1. So basically you have two half-lives. Two half-lives. Meaning that you have 2 times 5,700. 2 times 5,700, which is 11,400 years. I know it's a bit tricky. This question might be a bit tricky because of the ratio and how the ratio decreases or how it's quite tricky, I know. But you can think about it this way. Okay, you can try to solve it this way. Just bear in mind that the amount of carbon 12 is fixed. Amount of carbon 12 remains fixed. That's it. Other radioactive isotopes have different half-lives. Suggest the use of radioactive isotope with a half-life of 1 hour. If you have another radioactive isotope which has a very short half-life, 1 hour is very short compared to 5,700 years. Yes, this half-life is very short. One use would be the medical usage, medical treatment. The explanation, 1 hour. Why would 1 hour be much better? Well, because it's less harmful. Less harmful. Okay, say the name of one planet that has an orbit further away from the sun than Venus. So we have Mercury, Venus, whatever. We have Earth, Mars, Jupiter, all of these. You can say Earth. One planet that has an orbit closer than Venus, you have only Mercury. You can say Earth. For I, you can say Earth, Mars, Jupiter, Saturn, Neptune, Uranus, whatever. Venus has an average radius of 1.1 times 10 to the power of 11, an orbital period of 220 Earth days. Calculate the average speed. So speed equals 2 pi r over period, but he needs the speed to be in meters per second. The radius is 2 pi times 1.1 times 10 to the power of 11 meters, which is okay. The time or the orbital period is 220 days. You need to multiply by 24 hours, 60 minutes, and 60 seconds. Okay? Using our calculators, 2 pi times 1.1 times 10 to the power of 11 divided by 220 times 24 times 60 times 60. which is 36,000. 3.6 times 10 to the power of 4, okay, times 10 to the power of 4 meters per second. State the relationship between orbital speeds of the planets and their distances from the Sun. If you have a closer planet, the orbital speed would be much faster, yes, and as the distance increases, the orbital speed decreases. Okay. As distance increases, orbital speed decreases. Comets are balls of ice and dust. Some comets orbit the Sun. State how the speed of a comet changes as it orbits the Sun. Explain your answer using ideas about the conservation of energy as it keeps on orbiting the Sun. We need to talk about the speed. How does the speed change as it gets closer to the Sun? What happens? What happens to speed? Speed increases as it gets closer to the Sun. Speed, okay, increases. We can say kinetic energy increases while the gravitation potential energy decreases, right? And as it moves away, the kinetic energy moves away. Kinetic energy decreases while the gravitation potential energy increases. This is due to the conservation of energy. This is due to the conservation of energy. Energy cannot be created, okay? Be created nor destroyed. This is all due to what? Due to the orbital or the elliptical orbit of this planet or of this comet. Orbit of this comet or the elliptical orbits of any planet around the Sun creates this motion. As it comes nearer to the Sun, it has a faster speed. As it moves away, it has a slower speed due to its elliptical orbit. Okay,